In this video, we're going to talk about indeterminate forms. So far we talked about 0 over 0, infinity over infinity. When these two occur, you could use L'Hopital's rule. But whenever you have infinity times 0, infinity minus infinity, 1 to infinity, 0 to 0, infinity to the 0 power, you need to kind of manipulate in order to use L'Hopital's rule. And by the way, infinity times 0 is not always 0. And infinity minus infinity is not always 0 either. And 1 to infinity is not 1. 0 to the power of 0 is not always 1. And infinity to the power of 0 is not always 1 either. And we'll look at examples. So we have limit of x sine of 1 over x as x goes to infinity. As x goes to infinity, that goes to infinity. And then you get 1 over infinity. And 1 over infinity is like going to 0, isn't it? Just imagine 1 over a big number. That's like 0. And what is sine of 0? Sine of 0 is 0. So this is an example where as limit as x goes to infinity, you get infinity times 0. Now again, be careful. Don't just assume that this goes to 0, thinking that 0 times anything is 0. We're talking about limit, so be careful. So what are we going to do? Well, what we're going to do is, remember, x can be rewritten as 1 over x. Just think about it. Is 1 over x same thing as x? It is. So we're going to rewrite this as limit of sine of 1 over x over 1 over x as x goes to infinity. Now think about it. Is this same thing as this expression? It is. I just rewrote x as 1 over x. Now what happens as x goes to infinity? As x goes to infinity, this part goes to 0. So you get sine of 0, which is 0, and that goes to 0. So you end up getting 0 over 0. So now we could apply L'Hopital's rule because it's 0 over 0. So let's apply L'Hopital's rule. What's the derivative of sine of 1 over x? Well, it's going to be cosine of 1 over x. And then what is the derivative of 1 over x? Just pause the video and why don't you take the derivative of 1 over x. You end up getting negative 1 over x squared. All over, what's the derivative of 1 over x? Negative 1 over x squared. So what happens over here? Negative 1 over x squared cancels out. And what happens as x goes to infinity? Well, it's 1 over infinity, which means it goes to 0. What is cosine of 0? Cosine of 0 is 1. So therefore, this limit is 1. And you might want to confirm it with the graphing calculator. Graph this, and what happens? See, notice what happens when x goes to infinity. The y value will approach 1. So in this case, infinity times 0 was not 0. It was actually 1. Now what about when x goes to negative infinity of this? Well, it's going to go to negative infinity times, again, 0, because 1 over a negative big number is close to 0, so sine of 0 is 0. So we get negative infinity times 0. Again, using the similar method as last time, we can rewrite this as limit as x goes to negative infinity, sine of 1 over x over, I'm going to rewrite x as 1 over x over here. Now when you plug in infinity, negative infinity, you still get 0 over 0. So apply L'Hopital's rule. You end up getting limit as x goes to negative infinity. You get negative 1 over x squared cosine of 1 over x over negative 1 over x squared. That cancels out. Plug in negative infinity. 1 over negative infinity is like 0. So cosine of 0 is 1. Therefore, this thing is also 1. Now let's take a look at this example. What happens as x approaches 1? Now, do you remember the graph of natural log of x? As x approaches 1, this is natural log of x, the y value is getting close to 0. And recall that natural log of 1 is 0. But we're talking about limit. As x approaches 1, we're getting very close to 0. So what's happening over here? As we approach 1, you know that natural log of 1 is getting very, very close to 0. So what's 1 over a number getting very close to 0? It's going to be infinity. Just think about it. 1 over a number very, very close to 0. 1 over 0.00001. 1 over 0.0000001. You'll notice the number is getting to the infinity. What about this one? As you approach 1, remember approaching 1, not exactly 1. Again, the bottom denominator approaches 0. So this is going to be again 1 over number very, very close to 0, which means this thing is going to infinity as well. So this is like infinity minus infinity. And this is indeterminate. So what we need to do in this case, you probably want to use LCD and subtract the fractions. So you end up getting limit as x goes to 1 using the LCD. You're going to get x minus 1 minus natural log of x all over natural log of x times x minus 1. Okay, let's plug in 1 and see what happens. Well, unfortunately, now you get 0 over 0. Actually, this is nice because why? Why is 0 over 0 nice? That means we could apply, that's right, L'Hopital's rule. So let's do that. So let's apply L'Hopital's rule. So derivative of x is 1. Derivative of negative 1 is 0. Derivative of negative natural log of x is negative 1 over x. That's what we got on the top. What about on the bottom? We have to use a product rule. So natural log of x times the derivative of x minus 1, which is 1, plus x minus 1 times the derivative of natural log of x, 1 over x. So you end up getting limit as x goes to 1, you get x minus 1 over x. I use the common denominator, x. And on the bottom, you're going to get natural log of x plus x minus 1 over x. So I want to kind of simplify this. So this is a complex fraction. I want to multiply the top by x and then bottom by x. Because I want to get rid of the x. So you end up getting limit as x goes to 1 of x minus 1 on top. You're distributing the x here. And then you need to distribute x over here and x over here. You get x natural log of x plus x minus 1. So what happens when you plug in 1? You still get 0 over 0, don't you? So guess what? We have to apply L'Hopital's rule again. So what's the derivative of x minus 1? That's 1. And here you have to use the product rule, x times 1 over x plus natural log of x plus 1, and then derivative of negative 1 is 0. So you end up getting limit as x approaches 1, 1 over, it's 1 plus natural log of x plus 1. So what happens when you plug in 1 now? That goes to 0, you get 1 over 2. So that should be your final answer. So in this case, infinity minus infinity actually end up equal to 1 over 2. Okay, now we have limit of quantity 1 plus 1 over x to the x power as x goes to infinity. So when you plug in infinity, what do you get? You get 1 over infinity, which is like 0, and 1 plus 0 is like 1. So you end up getting like 1 to infinity, which is another indeterminate. And a lot of you might say that, oh, 1 to the power of anything is 1. But this is a common mistake by students, not always. So we're going to see what happened in this case. So in order to do this, right, whenever you have an exponent is a variable, this is what you might want to do. Let's just rewrite this as y equals limit as x goes to infinity of quantity 1 plus 1 over x to the x. So now what I'm going to do is I'm going to put natural log both sides. Put natural log so you end up getting, you remember when it's like natural log of a to the n, and one of the property was you could say the exponent comes in front of natural log, so n natural log of a. So we're going to use that property. So natural log of y is limit as x goes to infinity of x natural log of 1 plus 1 over x. Okay, using the property of natural log. Okay, now what happens when you plug in infinity? You get natural log of 1, which is like 0, times infinity. So you still get infinity times 0, which is another indeterminate. So we have to kind of manipulate this in order to apply L'Hopital's rule. So what I'm going to do here is I'm going to rewrite this as limit as x goes to infinity of natural log of 1 plus 1 over x over the x right here. I'm going to write it as 1 over x on the bottom, because 1 over x is the same thing as x on top. Now what happens when you plug in infinity? When you plug in infinity, you get 0 over 0. So now you could apply L'Hopital's rule. So let's take the derivative. So what is the derivative of that? The derivative will be negative 1 over x squared, the derivative of this, over 1 plus 1 over x, because derivative of natural log of u is u prime over u, all over derivative of that, which is negative 1 over x squared. Now let's think about this for a second. When you have a over b divided by a, what is that? This is like your a over here, right? They're the same thing, and that's like your b. That becomes a over b times 1 over a, isn't it? So a cancels out, you get 1 over b. So after you go through algebra process, what you're going to get is limit as x goes to infinity of 1 over 1 plus 1 over x. Now, what happens when x goes to infinity? Well, this will go to 0, so you get 1 over 1, which is 1. But that's not our final answer. Why? Because we said natural log of y is equal to this. And right now, this thing right here is 1. So, natural log of y is 1. So what is y then? How do you get rid of natural log? Well, we have to e both sides, and y equals e. Therefore, what was our y? This whole thing was our y right here. This whole thing is equal to e. And that's our final answer. And that's where e came from, actually. And now we got a limit of x to the x power as x goes to 0 from the positive side. So when you plug in 0, you get 0 to the 0 power. This is another indeterminate. So again, you'll notice the exponent is variable. So what we're going to do is we're going to say y is equal to limit as x goes to 0 from the right side of x to the x. Now we're going to take the natural log of both sides. You want to do that whenever the exponent is variable. Equals limit as x goes to the 0 from the right side, natural log of x to the x. And this is the same thing as limit as x goes to 0 from the right side. Exponent goes in front of natural log. Okay? Now what do you get when you plug in 0? Notice the graph of natural log of x again. As you approach 0 from the right side, the limit is approaching negative infinity. So this is like 0 times negative infinity. And you cannot apply L'Hopital's rule yet. However, if you rewrite this as limit as x goes to the 0 from the right, natural log of x, and then you're going to rewrite x as over 1 over x. And then plug in 0, what happens? It goes to negative infinity over, what's 1 over like 0? That's infinity. Now we could apply L'Hopital's rule. So you end up getting limit as x goes to 0 from the right. Derivative of natural log of x is 1 over x. Derivative of 1 over x is negative 1 over x squared. And this is the same thing as limit as x goes to the 0 from the right side of negative x. So what happens when you plug in 0? You get 0, right? But that's not our answer. Why? We said our natural log of y is equal to this, which came out to be 0. So natural log of y is 0, and you do e both sides, you end up getting y is equal to e to the 0, which is 1. Therefore, this whole thing right here, the answer becomes 1. Now let's look at our final example. We got limit of x to the power of 1 over x as x goes to infinity. So 1 over infinity is like 0, and this is infinity. So this is like infinity to the power of 0. And let's see what happens. Again, the power is exponent, so what you want to do is let y equals limit as x approaches infinity, x to the 1 over x. So you want to do natural log both sides. And then when you do that, that becomes in front of natural log. And you can write this as limit as x goes to infinity of natural log of x over x. So what happens as x goes to infinity? Well, think about the graph of natural log of x again. As x goes to infinity, what's the y value approaching? It's approaching infinity very slowly, isn't it? But it still goes to infinity on top. What about the bottom? As x goes to infinity, x also goes to infinity. So this is infinity over infinity, which means we could apply L'Hopital's rule. So you get limit as x goes to infinity. Derivative of natural log of x is 1 over x. And derivative of x is 1. So this is like same thing as 1 over x. So what happened as x goes to infinity? Well, 1 over infinity is 0. So now, that's not the answer though, because we said what? Natural log of y is 0. So you do e both sides, you get y equals 1. Therefore, this whole thing right here goes to 1. So in this case, infinity to the power of 0 is 1.